Hey there guys, this is Mr. Sheelan. This is going to be the video where I'm going to kind of walk you through, with some extra practice here, both writing in scientific notation and then taking numbers out of scientific notation. So just like the sig fig video, what I want you to do is I want you to be writing out all of these problems. So what I'm going to do is I'm going to be flipping through all of the different sets of problems. There will be 8 for writing in scientific notation and then 8 for taking out of scientific notation. So I'm going to show those to you, so make sure you pause the videos while I'm showing these to you so you can see what the problems are so we can move forward. So here are the 8 writing in scientific notation. So here are these 4. And then here are these 4. And again, these are the 8 for writing in scientific notation. Okay, and then for taking out of scientific notation, so here's what we're going to take out. Okay, there's the first 4. And then here is the other 4. Okay. Okay. So now that you have all 16 problems, what I want you to do is I want you to pause the video here. I want you to attempt these on your own and then come back and answer these, or see if what you answered is correct from the answers that I give. So again, pause the video, try them out on your own. Okay, so let's give this a good old try. So writing in scientific notation. So remember, part of writing in scientific notation here is not only do we have to not only are we writing in scientific notation in order to shorten them, we're also trying to make sure we keep sig figs. Okay, that's also an important process and step here too. So let's make sure we keep these sig figs as well. So here, okay. Oh, and also catch me, like if I write something like in class, if I have something where I didn't keep sig figs for scientific notation, call me out, please. Okay, because it's possible there's some issues there. There's some, there may be some answers that I say, that's on the key. That may not be exactly correct. So just, always got to look out. So anyway, let's get to this. So here we've got 0.00006. So we have a sig fig of 1. Okay, so I know that off the top of my head, but what I need to do is find that good old decimal. And I'm going to be moving it over to the right because I need this guy right here. I need this guy to be, basically at the forefront of my scientific notation of this number. So let's count. So 1, 2, 3, 4, 5. So because it's 1 sig fig, it'll just be 6 times 10 to it'll be 5th power. But what 5th power? Is it positive or negative? Well, it's going to be negative because we moved it to the right. Okay, so every time you move that decimal, when you're putting it in scientific notation, when you move that decimal to the right, it's going to be a negative number. If it's already in some kind of scientific notation, you're subtracting the number of jumps from the already established exponent, okay, which we'll see a bit on the other side, on the other 4. Okay, right here, again, we have 1 sig fig in this number. It is 60. Okay, and we need to put this in scientific notation. But first we need to find the decimal, which is right here. And we're going to move that decimal just once to the left. So it's going to be 6 times 10 to the 1st power. Easy peasy. Guy here, 6.7. Why so many 6s? I don't know. I got this off a worksheet. Okay. So 6.7 here. Find that decimal. Actually, now looking at it, do we need to do anything here? Nope. That's silly. That's weird that that actually had this. Okay, you could just keep it 6.7 times 6.7, or you could, if you really wanted to, you could write 6.7 times 10 to the 0th power. Okay, you could do that. So. If you're wondering what that is, pop it in your calculator and see what you get. Okay. Okay. So let's continue. So now we've got, looks like here we got 2 million. Find that decimal. It's out here. Now we're going to take that decimal and we are going to jump with it. So 1, 2, 3, 4, 5, 6. So our final answer, and just make sure, 1, 2, 3, 4, 5, 6, yeah. So our final answer here, oops, don't put that decimal. Well, just the decimal is fine, because again, we only have one sig fig. So it's going to be 2 times 10 to the positive 6th power, because we move that decimal to the left. Okay. Okay, so we've got 5,400 times 10 to the 3rd power. This is an incorrect scientific notation, so we need to make sure we put it in correct scientific notation. Find the decimal in just this guy right here. It's going to be right there at the end. And we're going to put it here between the 5 and the 4, because remember, when we write these out, it needs to be number point something something something, or just number times 10. Remember, the first value has to be between 1 and, the notes say 1 and 10. It's really, it has to be, 1 or 9 is what the first value should be. So here we've got to move that decimal between the 5 and the 4. And we're going to move it 1, 2, 3 to the left. So because we moved it to the left 3 places, we're going to add that to our already established exponent. So it's going to be 5.4 times 10, okay, times 10 to the 6th power. Okay, decently large number. This guy, okay, so find that decimal, move it over. Looks like we moved it once over to the right. So it is going to be 6.3. Now, you could write it like this. It could be times 10 to the 0th power. Okay, you can do that. Or you can just write it 6.3. Okay, whichever way works, because realistically speaking, is this a number you put in scientific notation? No, because it's small enough already where we don't really need to. Okay, this guy, now because we've already worked with times 10 to the 0th power already, we should know what this is now. So all this is just 6.2934. You can keep it, just like this, or you can write it out like this. It's the same thing, doesn't matter. And then 33 times 10 to the negative 3rd power. Find that decimal right there, and we've got to move it once to the left. So since we are moving it to the left here, that means that we are going to add to our already established exponent. So it'll be negative 3 plus 1, which is a negative 2. And then we have our writing in scientific notation problems all done and all figured out. So hopefully these didn't throw you off, like these 10 times, oh my goodness, times 10 to the 0th power. Hopefully it didn't throw you off too much. If it did, make sure you just keep asking me about this. Just, again, pop it in your calculator, see what you get. What you should get is 1, by the way. Okay, it should be times, it'd be like 6.2934 times 1. It would be, like here, it'd just be 6.3 times 1. So that's why this is fine just to write it as 6.3, okay? Okay, so that's writing in scientific notation, so let's now take out these numbers from scientific notation. Okay, so here we got 0.9 times 10 to the negative 1, or first power. Find that decimal, and because it's a negative, or remember, a negative 1, and when we take it out, we just do the reverse of putting in. Okay, so if we were putting this into scientific notation, which, by the way, this is incorrect scientific notation, if we were putting this in scientific notation, it would actually go one more, but in the reverse, because when we put these in scientific notation, a negative number results in moving to the right. So in this case, when we take it out, we got to move the decimal back to where it was originally, which is towards the left. So we're just going to move this to the left 1 space. So what we got here is 0.009. Okay. Which, wait a minute. That's not right. Oops, that's not right. It's just 0.09. Yeah, that's what it is. My bad. Not that, this. Okay. So 2 times 10 to the 5th power. So find that decimal right there. And we're going to move our decimal here 5 spaces to the right, okay? Because again, this is the opposite that we're doing here, opposite of putting it in. So we're going to move it 1, 2, 3, 4, 5. Fill in those zeros. And we have 200,000, okay? Cool. I think that should be 2.04. That shouldn't be 204. Let's see, I'm double checking here. Oh, nope, it's 204. This is 204 times 10 to the second power. So again, it's incorrect scientific notation, but that's part of the practice here. Find that decimal. It's right here. And we're going to move that guy 2 to the right. 20,400. Okay. 1.71 times 10 to the 7th power. Find that easy peasy decimal point, and we're going to move it 7 places to the right. So 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. And then we have 17,100,000 for our answer here. Okay. And then the last final 4. Okay. So 8.4 times 10 to the 5th power. Decimal 1, 2, 3, 4, 5. Okay, so 8, 4, 1, 2, 3, 4. 840,000. Same thing here, but it's a -5, so we're not going to go to the right, we're going to go to the left. So 1, 2, 3, 4, 5. It'll be 1, 1, 2, 3. Ooh, boy, let's see. Got 0, 0, 0. Shoot, I ran out of space. Let me try that again. 1, 2, 3, 4, 5. There are 4. Just want to make sure. Okay. So 0.000075. Here, just 4. Because remember, that's just 4 times 1. That's all this is. Times 10 to the 0th power, it's just 1. And then this guy here, 3.8 times 10 to the 3rd power. Find that decimal, move it 3 spaces to the right. So 1 around the 8, 2, 3. So just 2 zeros, so 3,800. Now, all I will say, I don't really want to walk, well, not yet, at least. All I'll say is that you can do this on your calculator. I will make some videos and I'll make some videos on how to do that a bit in the future. So hopefully you already know how to pop this into your calculator. If not, I will make a video on that as well to help you out with putting these things into your calculator. So instead of having to do this by hand, you can literally just put it in and be done with it. But I just don't want to just say how to do it. I want to show you how to do it. So I'll have a video out like that showing you how to do that. So anyway, that's it for this video, guys. So thanks for watching. If you still have any questions concerning this, make sure you ask me. And if not, then I'll see you later.